Okay, let's unpack this. For years, the big problem with solar power has always been, well, it needs sun, right? A clear sky.
Right, the Achilles heel.
Exactly. But what if the very thing that usually stops it, rain, could actually generate power?
Hmm?
Today, we're diving into this really groundbreaking idea, this innovation that might make solar truly all-weather.
Yeah, it's fascinating stuff.
Our mission is to kind of explore this emerging rain-powered solar tech, see what its potential is. And we're using Aberdeen, South Dakota as a case study, drawing on some recent research.
And what's really interesting here, I think, is how this tech goes right after the main limitations of, traditional solar.
The intermittency.
Exactly. It's not just about getting the most out of sunny days anymore. It's aiming for consistency, making renewable energy reliable whatever the weather's doing.
And Aberdeen, South Dakota. That's a brilliant place to look at this, isn't it?
It really is.
Because, despite being pretty far north, the data we looked at shows it actually has surprising solar potential. We're talking an average of, 5.4 peak sun hours a day for fixed panels?
Yeah, that's solid. And peak sun hours just means the equivalent hours per day of maximum sun intensity, for anyone wondering.
Right, and with tracking systems, it gets even better, like 6, maybe even 7.3 hours.
Yeah.
That stacks up really well against lots of other places in the U.S.
It does. But Aberdeen's climate also throws up some unique hurdles, which makes it a perfect testbed, really.
Like what?
Well, you've got those big temperature swings between seasons, pretty clear skies in spring and summer, sure, but also quite breezy conditions, winds up to 32 mile per hour sometimes, and crucially for this topic, frequent rain and snow.
Wow. Oh.
So, yeah, the solar potential is definitely there, but you absolutely need tech that can handle all that variability reliably.
So how does this actually work then? What's the trick? How do you get electricity from raindrops when normal panels just kind of give up?
Okay, so this is the clever part. It's work coming out of China, developed by scientists there. They use a super thin coating of graphene on the solar panel.
Graphene.
Yeah. And rainwater, even if it looks clean, it has dissolved salts in it, positive ions, like calcium, sodium.
Right.
So when these raindrops with their positive ions hit the graphene layer, which is rich in electrons, it creates this sort of temporary tiny battery effect. They call it a pseudocapacitor.
Huh. Like each drop makes a tiny charge.
Pretty much. Think of each drop hitting the panel, briefly charging this tiny capacitor right there on the surface, and then it releases that energy as electricity.
Wow.
Yeah.
That's genuinely incredible. So, okay, traditional panels might drop to 10, maybe 25% of their output in rain.
If you're lucky, yeah.
But this all-weather approach sounds much more resilient. What kind of numbers are we talking?
Well, look, it's still developing technology, right? But the research points to some serious promise, especially for places like Aberdeen with that mixed weather, these all-weather panels. They could potentially keep producing at maybe 30–40% capacity, even during rainfall.
30 to 40%, that's a huge difference.
It's a massive shift for consistent power supply, especially if you think about integrating it into hybrid systems.
Right, combining both types.
Exactly. So, put it this way. Maybe a standard 10-kilowatt home system in Aberdeen gets you, say, 42–45 kilowatters on a good, clear day.
Okay.
With this rain tech potentially mixed in or layered on, that same system might still generate a good chunk of power, 30–40% of its peak when it's raining. That really smooths out that signal drop-off you usually get.
Yeah, those numbers definitely make a strong case for consistency. But does it solve everything?
Yeah.
What about practical stuff like keeping the panels clean? That's always a thing with solar.
Good question. And yeah, the research touches on that. Rain is great for generating this extra power, and it does help rinse out some dust, which is a bonus.
Okay.
But it's not a magic cleaning solution. You still get things like, believe it or not, pollen sticking to panels. That can actually cut performance by up to 15%.
Pollen, wow, okay.
Yeah. But still, the rain provides some natural cleaning for dust, and it can also cool the panels down, which sometimes helps efficiency overall.
So what's the bottom line here for you listening? For homeowners or anyone looking at solar,
Wow.
it feels like this vision of steady, year-round renewable energy, even in places like Aberdeen, with its ups and downs weather-wise, it's getting closer, isn't it?
It really is, especially with these rain-powered innovations and thinking about hybrid systems.
Yeah. It really changes the calculation potentially for solar in cloudier places.
Yeah.
Maybe it makes it viable where people didn't seriously consider it before.
Absolutely. And if you kind of zoom out, look at the bigger picture, it raises a really interesting question.
Which is?
If we can genuinely start generating significant energy from rain, what does that do for solar adoption globally? especially in regions we don't normally think of as sunny.
Ah, right. Could it shuffle the deck on which countries or climates become renewable energy leaders, moving beyond just deserts and sunny coasts?
Exactly. How might that redefine leadership in renewables? It's something to think about.
Definitely is. Imagine a future where your energy supply isn't so tied to the weather forecast, but more to clever engineering turning rain into power.
Less complaining about the rain, maybe.
Huh? Only complaining about the pollen then, right? It's an exciting thought. Thank you for joining us on this deep dive into where energy innovation is heading.